All right, section 1.2, looking at trigonometric functions, but we're going to do a little algebra review here, talking about rationalizing a denominator. We don't want to have a radical or square root symbol in our denominator. So to rationalize it, we technically multiply the denominator by itself. So we don't want to change the value. We'll multiply by a value of 1. The square root of 13 over square root of 13. On the bottom gives me the square root of 169, or if you will, 13 squared, which cancels the square root. And that gives us 2 square root of 13 over 13. We'll also be looking at the Pythagorean theorem here. Here, a is 2, b is the square root of 5, looking for c. So everybody remembers the Pythagorean theorem is a squared plus b squared equals c squared. Substitute them in. 2 squared is 4. Square root of 5 squared is 5. 4 plus 5 is 9. Square root of 9 is 3. There's my hypotenuse. Now, we can use that also when finding the distance from the origin to a point. So from the origin, draw a segment out to 3, 4. Create a right triangle always to the x-axis. That's common practice in trigonometry. So our horizontal distance is 3. Again, our vertical distance will be 4. So here's my 0, 0. There's my distance. Here's my horizontal distance of 3. There's my vertical distance of 4. There's my Pythagorean theorem. Okay, instead of c, we put d for the distance of the segment. Nothing changes. Plug in the numbers, crunch the values, add them together. D is equal to 5. Another little algebra review we're going to do is graphing lines. So you'll see a lot of equations in standard form. And if they're set equal to 0, which they should be because we want our angle to be at the initial side, being the x-axis, vertex at the origin. So you'll see a lot of standard equations for our line with a standard form equal to 0. So again, solve for y, make your y term positive, divide by 3, and there's my equation. Y equals 5/3 x plus 0. We're going through the origin. So I'm going to plot a point there. My y-intercept is the origin. My slope is 5/3. So we'll plot a point here. We'll go up 5 and to the right 3. We'll go down 5, left 3. There's -3, -5, and there's my line. So in this case, we could have this angle here, initial side x-axis, to this terminal side of that line, or we could go all the way around to this terminal side for our theta. All right, our 6 trig functions of angle theta are as follows. We have sine, cosine, tangent, cotangent, secant, cosecant, abbreviated as sin, cos, tan, cot, sec, and csc. Now, how do we define these 6 trig functions? Let's say we put the point xy anywhere out there in quadrant 1, 2, 3, or 4. With the origin being your vertex and the origin to point P your terminal side, there it is in standard position. There's my theta. You create a right triangle. Remember, from any point, always draw a perpendicular to the x-axis. You create the Pythagorean theorem where x squared plus y squared is equal to r squared. R being this distance is always going to be equal to the square root of x squared plus y squared. So that's a formula that we're going to have to log into the memory. It's just solving for c, if you will, of the Pythagorean theorem. We just put an r there instead. So sine of theta, of this angle theta, is the ratio y over r. Cosine theta is x over r. This x value over r. Tangent of theta is y over x. So once you find this r value and you have your point here, you're pretty much able to just plug in y over r, x over r, y over x. Well, in this case, x could possibly be a 0. So we have to make sure x is never going to be equal to 0 because that would be an undefined value. Cosecant of theta will be r over y, and since y is in the denominator, y cannot be equal to 0. Secant theta is r over x, and so x can't be in the denominator, just as a 0 in the denominator, just like it was for tangent. And cotangent is x over y, where again y, just like cosecant, can't be 0 in the denominator. And if you take a really close look here, you're going to see a pattern. And I lined them up like this as follows. Notice that y over r, its reciprocal is r over y. Sine and cosecant, their ratios are always reciprocals of each other. Cosine and secant, reciprocals. Tangent and cotangent, reciprocals. All right, so remember that when we're trying to find. Normally what people will do is they find sine, cosine, and tangent, and then they just remember to flip their answers accordingly to their reciprocal trig functions, which we'll turn those into identities we'll talk about later. Our quadrant angles, let's say we had 0, 90, 180, 270, 360, which is back to 0. So hint, 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 this row is going to be the exact same as this row. And if you notice, we're going to have a bunch of undefined values here because remember, these are the 4 that couldn't have x or y in the denominator. So if I take my xy coordinate plane, and let's just say I go 1 to the right, up 1, left 1, down 1, give them the point values. For those 5 angles, our quadrant angles, our r value is 1. So for sine and theta being y over r, it will be 0 over 1, which is 0. 90 degrees will be 1 over 1, that's a 1. 180 degrees will be 0 over 1, that's a 0. 270 degrees will be negative 1 over 1, which is negative 1. And 360 back to 0 like we had up here. Cosine of theta is x over r, so okay, x coordinate 1 over 1. 90 degrees, 0 over 1. 180 degrees, negative 1 over 1. 270, 0 over 1. And 360 should be back to the same as we had for 0. 1 over 1, which is 1. Tangent of theta, y over x. Okay, 0 over 1. That's a 0. 1, y over x, 0. So you can see that's undefined. Over at 180, 0 over negative 1, that's a 0. 270, negative 1 over 0, that's undefined. And back to 360, we're back to the same answer as we had for 0 degrees. Cotangent theta, okay, that's x over y. 1 over 0, or if you look here, the reciprocal of tangent, undefined. What was undefined before is y over x at 90 degrees was 1 over 0 is now 0 over 1. That's a 0. So a lot of undefined and zeros, they are technically reciprocals of each other. So at 180, 0 over negative 1 for tangent would now be negative 1 over 0 for cotangent, and that's undefined. Undefined here for at 270 was negative 1 over 0. Well, flip that. That's now 0 over negative 1. That's a 0. And at 360, we should get the same answer as what we had at 0 degrees. Secant, that's r over x. Now remember, secant was the reciprocal of cosine. So 1 over 1, still 1. 0 over 1, well, that's 1 over 0. Undefined. Negative 1 over 1 is now 1 over negative 1, still negative 1. 0 over 1 is 1 over 0, is undefined. And 360 is same as 0, we're back to 1 over 1, which is 1. Secant theta, which is r over y, which is the reciprocal of sine. 0 over 1, flip it, 1 over 0, that's why it's undefined here. 1 over 1 is still 1. 0 over 1 flipped is 1 over 0 is undefined. Negative 1 over 1 is 1 over negative 1, still negative 1. And 360 is back to the answer we had at 0 degrees. All right, example 1. Find the function values of an angle. The terminal side of an angle theta in standard position passes through the point 12, 5. Find the values of the 6 trig functions of angle theta. Okay, so here's my 12.5. Here's my initial side. So here's my terminal side. Again, drop a perpendicular side to the x-axis to build this right triangle so we can use our Pythagorean theorem. There's my r. Here's my x being 12. Here's my y being 5. R is equal to the square root of 12 squared plus 5 squared. So we'll have all three sides of our triangle for this angle theta right here. So let's see, that's 144 plus 25 is 169. The square root of 169 is 13. All right, so sine of theta, 5 over 13, y over r. Cosine of theta, x over r, 12 over 13. Tangent of theta, y over x, 5 over 12. Okay, so again, this all depends on your favorite way to do this. You find these three. If you want to start at the top and work your way down, that's fine. So cosecant is the reciprocal of sine, so that's 13 over 5. Secant is the reciprocal of cosine, that's 13 over 12. And cotangent is the reciprocal of tangent, so that's 12 over 5. So some people write these three down, then they go cosecant, secant, cotangent. The other half of the students I've worked with, sine, cosine, tangent, and then they go right to cotangent, then secant, then cosecant. I think it's something to go, if you notice the pattern, sine, then the prefix cosine, tangent, and the prefix co on the tangent, secant, prefix cosecant. Some people like them in that order, and they kind of like make a U shape for their answers when they do the reciprocal of the right side. 6 of one, half dozen of the other. Whichever works best for you will work for me. Example 2, finding the function values of an angle, the terminal side of an angle. Same type of situation, but now we're at square root of 2 comma negative 3. Find our 6 trig values. So we draw our r, build our right triangle, put in x, put in y, do our Pythagorean theorem. The square root of 2 squared is 2. Now, this is optional. If you want to put the negative 3 and square it, that's fine. If you want to put the 3 in and square it, either one's fine by me. You're still going to get a 9 plus 2 is 11. All right, well, my mouse is a little sensitive. It already gave us the answer for sine of theta, y, negative 3 over r squared 11. Traditionally, we want to have this in a simplified radical form, so we don't want the square root on the bottom. Multiply the top and bottom by the square root of 11. There's my answer. Cosine of theta would be the square root of 2 over the square root of 11. Multiplying the square root of 11, top and bottom, gives me the square root of 22 over 11. Tangent is y over x, so negative 3 over the square root of 2. Again, rationalize the denominator, negative 3 square root of 2 over 2. Now, let's work our reciprocals. So cosecant, take this fraction and flip it. That would give me the square root of 11 over negative 3, and you can leave the negative on the bottom or you can put it out in front here. Either way is fine by me. Cosine, don't flip this one. Flip the original. Square root of 11 over 2 is my secant theta. To rationalize it, we just multiply the square root of 2, top and bottom. If you did flip this one, you're going to have to rationalize it and reduce it. So just a little bit of a time saver there. Cotangent, we'll flip this fraction here, square root of 2 over negative 3. If you want to leave the negative on the bottom, that's fine. Or if you want to put it in front, I'm okay with that too. All right, example number 3. Oh, here we're going to build angle to a line. Like I said, here's my standard form, set equal to 0. Oh, they put a restriction on my x. They said x has to be less than or equal to 0, which means x is going to be negative or 0. So, okay, so let's solve this for y. Add over the 2y, divide by 2. There's my equation. So I'm going to graph it. There's my origin, up 3, right 2, down 3, left 2. Now remember, x had to be negative. This is positive 2, 3. Don't want this point. We want this point, negative 2, negative 3. So this is the theta we're working with. So again, from this point to the x-axis, draw your perpendicular, label your sides. There's r, x is negative 2, y is negative 3. Find your r again. If you just want to go 2 squared plus 3 squared, I'm all for it. Either way, you're going to get 4 plus 9. The square root of 13 is your r value. Sine of theta is negative 3 over the square root of 13. Again, we'll rationalize it to negative 3 square root of 13 over 13. Cosine is negative 2 over the square root of 13. Rationalize it. Tangent is going to be negative 3 over 2, which simplify the signs, 3 halves. Okay, reciprocal time. Cosecant, flip this fraction. Square root of 13 over negative 3, and again, same thing with the negative, put it wherever you want. Cotangent, flip the original, square root of 13 over negative 2, put the sign where you like it. Tangent, flip the positive 3 halves to get 2/3. And example 4, finding functions of values of quadrantal angles. Find the 6 trig functions of an angle. So we'll have to be going back to that chart we had. So an angle of a negative 180 degrees, add 360 to it, it's 180. So go to that 180 column. So from your table, sine of theta is 0. Sine theta is negative 1 for 180 degrees. Tangent of 180 degrees is 0. Flip 0 over 1, 1 over 0, undefined. Flip negative 1. Tangent, flip it for cotangent, undefined. 450 degrees, we're going to subtract 360 degrees from it to get 90 degrees. So from the table, sine of theta is 1, cosine theta is 0 for at the 90 degree spot. Tangent is undefined. Cosecant is 1, flipping the 1. Flipping the cosine is undefined. Cotangent is 0, flipping the 1 over 0 to 0 over 1. An angle in standard position with a terminal side at 0, negative 5, that puts your point on the negative y-axis, so that's at 270 degrees. It really doesn't matter how long that r value is, 1 or 5, it's still going to be 0 over 5 or 5 over 0. So from the table, sine of theta is negative 1, cosine of theta is 0. Tangent, undefined. Cosecant, negative 1. Secant, undefined. Cotangent should be a 0. And that's how we find our ratio values for our trig functions.